very good morning and good afternoon to people in different time zones. I'm Rohit Salecha. I've been with Not So Secure for the past three and a half years now, and I've been in the information security for quite some time now. Before starting with my information security job, I was an application developer myself, and the length, breadth, and depth of information security is really what absorbed me into information security. And since then, I've just been working with mobile applications, web applications, developing small applications for trainings and testing and so on. So this is, as Alan said earlier, this is a small glimpse of our course on application security for developers, which is a 2-day hands-on course specifically for developers that we have designed. So today, what we are going to listen to is firstly why we need application security. Then we'll understand the OWASP top 10 and why OWASP top 10 is so important to follow. Next, we'll understand the attack surface. So I'm not sure if you guys have heard about this term, but the attack surface is something that the developers really need to understand very well. Then we'll also discuss some popular bugs. I'm sure you must have seen these bugs across the bug bounty platforms. And finally, we'll end with some key takeaways from our webinar today. Okay, so why do we need application security? So this is a block diagram that we created for one of our clients when we were pen testing their entire internet-based services. The agenda was simple with them: 5 days in hand. Please search through the internet, find out what our assets are lying around in the internet, and identify if there is any way in which we can get inside or someone can get inside our network from the internet. They had laid down lots of expensive firewalls and a lot of different kinds of security solutions. So they were pretty confident that it would not be possible. However, we found one particular application that was hosted over the internet. It was a small application, and from the looks of it, it seemed that the application was created just for some temporary event, and they forgot to decommission it. In that application, we found a blind SQL injection vulnerability. Now, from that blind SQL injection vulnerability, we were able to execute SQL queries on the MS SQL host Windows 2012 hosted on the Windows 2012 operating system. Now, after being able to execute SQL statements on the MS SQL host sitting outside over the internet, we identified that the application was actually accessing the database with the SA user. The SA user is the root user or the super administrator user in the MS SQL database. Now, in MS SQL database, there is a procedure called as XP_CMD shell, using which we can execute operating system level commands using the normal SQL injection vulnerability. So sitting over on the NSS box on the internet, we were able to execute operating system level commands on the Windows 2012 machine. Now, after gaining foothold on that particular machine, we then tried to navigate into the network and try to get our hands on some other machines in the network. However, we could not get much information from this particular machine. So we tried all the other post exploitation techniques like hash dump, mimikatz, etc. But we did not get much information. So what we did is we tried to search for other MS SQL instances within the network, and we tried to spray the password of the SA user that we had in hand. And luckily, we had one more machine with Windows 2003 operating system, which was also hosting an MS SQL database and was using the same password as the SA user of the machine that we had compromised. Now, sitting over on the NSS box, over the internet, we were able to gain access to the Windows 2003 machine using the exact same procedure, that is using the XP_cmd shell and then executing operating system level commands. Now, what we did here is performed all the post exploitation techniques again, hash dump, mimikatz, etc., and we found out that the domain administrator credentials on that particular machines. So using those domain administrator credentials sitting over at the over the internet, we were able to gain access to the enterprise administrator or the domain administrator of that particular organization. So in summary, using a simple SQL injection vulnerability, we were able to get inside the network and gain access to the enterprise administrator credentials, right? So again, it was not just the SQL injection issue. The issue was of course, the SQL injection. Second is using super administrative privileges. So the least privilege approach was not used. Thirdly, using same passwords across the machines, across different machines. Now, these are some of the issues that are there in a lot of places internally, because people generally give more focus on the services that are outside and less focus on services that are running inside, or the security of the internal network. All right, now let's look at the OWASP top 10. So OWASP top 10 is so OWASP basically stands for Open Web Application Security Project, which is an open source community which basically deals with uh, these 10 vulnerabilities which are released every 3 or 4 years, right? And as you can see, we have the list from 2010, 2013, and finally we have the latest one, that is the 2017. Now, the interesting thing that I want to discuss about OWASP top 10 is why is cross-site scripting vulnerability, which was on second rank in 2010, went down to third rank in 2013 and went further down to the seventh rank in 2017. And if you see the CSRF issue, that is on the fifth rank in 2010, it went down to eighth rank in 2013, and in 2017 it's completely removed. Whereas the injection issue is always maintained at top. If you see these statistics, you'll find that the injection issue, the number of injection issues have been reducing since 2010, but still it is still remaining at top. Why is this really happening, or why is it designed in that way? The answer to that is because of the impact. So even if you have a 3000 page application having 10,000 parameters, even if one single parameter is having a SQL injection issue or a command injection issue, right? Your entire the attackers can basically get hold inside your network. Now, what about the cross-site scripting issue? Why is it reducing, right? It's reducing mainly, uh, the rank has been reduced mainly because of two main reasons. The first reason is that developers are now making use of a lot of good web frameworks that have out of the band functionality or out of the band uh, functions to block cross-site scripting. Like a lot of web frameworks like .NET MVC or Java, uh, they have functions using, you just have to use that function before sending out the response to the user, and the entire data is HTML encoded, and which basically completely blocks out cross-site scripting. Same with CSRF. CSRF again, today we have the same site cookie, same site attributes being put on the cookies, but a lot of these web frameworks are also having inbuilt implementation to block CSRF attacks by generating CSRF tokens randomly, right? So first is web frameworks, and second is the browsers. So browsers are gaining traction on security, have gained a lot of traction on security, and are trying their level best to weed out all of these client-side issues, right? Now let's understand the attack surface. This is a typical request for a web application. Here we have the post, that is the method, that is the post get put delete head, etc. Then the resource, that is login page or your sign up page, etc. Then we have the host header, which basically is meant for a particular host in your organization or in your server network. Then we have the user agent string, which identifies the client, whether it's a mobile client, whether it's a desktop client, etc. Then we have the most important header, that is the cookie header. The cookie header is a simple key value pair where the value will be unique for 1 billion users logged in. So if there are 1 billion users logging into Facebook, the value of this cookie header will be different for all those different users. And that is how the web applications, they basically maintain the state, right? HTTP is basically a stateless protocol, but it is this cookie header that gives state to the web applications, and that's how we maintain sessions. And finally is the post data, that is the user supplied data that is sent to the server. Now, the biggest fallacy is amongst the developer community is that they believe that only the user sent data is under the control of the user, right? What a lot of developers do not realize is that anything in this HTTP request can be tampered with, and hence this entire HTTP request is what we call as the attack surface. So for example, in one of our pen tests, we actually found a SQL injection issue through the user agent string. So it was an analytics application, and as you can imagine, in an analytics application, it is very much sure that the application will take the user agent string and put it into the SQL database for performing analysis. And that's why we tried to perform a SQL injection issue in that, and we succeeded with that, right? And what is the remediation for that? Validation of untrusted sources. So anything in this HTTP request is untrusted, whether it is the method, whether it's the host header, the user agent string, the cookie value, etc. Anything cannot be trusted. So what is the best way to remediate this? Validation of untrusted sources. So if you are accepting a username from the uh, from the from the client, ensure that at the server side you are doing a proper whitelist based check. And these are some of the examples of the bug bounty programs where people have not checked, or people have not done any testing on the user supplied input. Here the people have actually exploited the request headers and gone ahead and performed various different kinds of issues. Now let's look at some popular bugs. Now, XML as an input. So XML file, a lot of applications today process XML files, right? Now here on the screen as well, you can see that there is a simple API which is basically accepting an XML as an input and processing that XML file, and then spooling out the data. So it's basically extracting data from the XML file and spooling it out. Now what can go wrong in this? In XML, in the XML standard, we can declare what is something called as an entity. An entity is basically a placeholder for can be talked about as a placeholder which holds certain value, and that same value can then be referenced later on in your XML document. So for example, here I'm declaring an entity called as XXE, and to this entity I'm declaring the value of an internal file. So using the system keyword, I can reference an internal or an external file, and using that file I'm basically referencing the value of that file in my in my XML document as ampersand XXE semicolon. And when I send this to the application, in response, it is giving me the file that I requested for. So using an XXE issue, you can basically go ahead and read any internal file. In case of PHP, you can also go ahead and execute code if there is the extend framework if the extend framework is enabled, right? So XXE is pretty much prevalent because XML is everywhere, right? We live in the IT world is living within a lot of XML parsers that are running in the background. Now, what else can we do with XXE? If you have an instance running on an AWS, or if you have an application, a vulnerable application running over AWS, we can basically go ahead and reference the AWS EC2 instance, the security credentials EC2 instance metadata URL to get the AWS temporary credentials. Now, what if we cannot do anything? We cannot read any file. So we cannot read any file that is having some information or is a sensitive file, or we cannot, or the instance is well protected or is not hosted on AWS, right? So basically, there is no way in which we can actually highlight the impact of our XXE vulnerability. So what can we do in this kind of a scenario? What if I supply this file? So this file is basically what we call as the billion laughs file, and what this XML file will do is basically print this LOL string, the simple LOL string, 1 billion times. Now you can imagine what the kind of load that the web server will have if it tries to print this LOL string or process this LOL string 1 billion times. It will immediately shut down, right? It will immediately crash, right? So XXE is a very important issue, and the best way to remediate this issue is to identify if you are accepting XML as an input anywhere in your application, or is XML coming in as an input anywhere in your application. XML can come in as an SVG file, or it can also come in as a docx file, right? So you need to identify if there is XML being passed as an input. If it is being passed, then, or in your source code, you can basically go ahead and check if you are using any XML library for parsing. Then what you need to do is search how to disable entity and external entity processing, or how to disable DTD processing. So these are the two things that you would need to search for. So for example, in ASP.NET, the default XML text reader library, you can disable DTD processing using the simple reader.dtd processing is equals to DTD processing.prohibit flag. So once you do this, even if somebody sends a malicious XML file, your XML parser will not process it, or will probably throw an error depending upon the implementation. And this is the monetary value that the XXE vulnerability holds on the HackerOne bug bounty platform. Let's look at another interesting vulnerability that is called as SSRF, or server-side request forgery. Now, SSRF, first let's understand where exactly or how an application can be vulnerable to SSRF. So if the application is accepting a URL or an IP address as an input to basically load some server, some resource from an external system. So here, as you can see, we are giving the URL of the image to the server. The server is going ahead and requesting this URL, fetching the image on our behalf, and then showing it to us on our screen. So this is a scenario where the server is basically processing the request on our behalf, or is it processing the request for a particular resource on our behalf. Now, instead of this URL, what if I pass something like this, like a local host 9200 slash indexes, which is the default Elasticsearch query, right? So 9200 is the default port on which your Elasticsearch is running. Now, what if I pass this particular URL to the application, right? The application or the server, if it is not properly validating, it will not know whether this particular request needs to be served or not. It will whether this particular request is genuine or not. It will simply go ahead and request for this particular resource. It will get the data and show the data back to the attacker or the person who has requested it. So in this scenario, the attacker can basically bypass the firewall and gain access to any of these services that are running inside our network. Elasticsearch, Kibana, Memcached, Redis, MongoDB, just to name a few. Basically, any service that is running over HTTP or HTTPS can then be requested by the attacker by exploiting this server-side request forgery issue. And SSRF on an AWS instance, we can easily fetch the AWS metadata API and get hold of the AWS credentials as well. So how do you remediate SSRF? The latest and the best way to practice, if you're running an AWS instance, then you might want to look at the new instance metadata service version 2, which requires you to send a request header as well in the request for fetching the security credentials. So you can no longer simply request for this metadata API and get your AWS temporary credentials. You need to also send an HTTP request header, which the attacker cannot inject in case of an SSRF issue. So IMDS v2 is something that you would want to enable. But on a generic way, authentication of internal API endpoints is something very important, right? So whenever we do an internal pen test, we generally identify a lot of API endpoints of Elasticsearch, Memcached, Redis, etc. are simply easily accessible. Once we even found a Jenkins instance running without authentication or with using default credentials, right? So authentication of your internal API endpoints is very important. So if your internal API endpoints are authenticated, you are mitigating the SSRF issue. You're mitigating the impact of the SSRF issue. Whitelisting of domains is something that can be done. So for example, if you are allowing users to load, let's say, images from Google or from Facebook, then you can basically whitelist the domains from which the server will request the particular images. If there is any request coming in from for any other domain or any other IP address, then you can simply reject that request. Lastly, and most importantly, what we can do is response filtering. So here, when the server is sending, so let's say the server accepts a URL to download an image on behalf of the user. Now the server basically sends a request to that particular URL. In response, the URL, the domain to which the request has been sent, in response, the the server will get the image, and along with that, in the response headers, there will be a content type header which will be of that of an image, right? But if the attacker, instead of giving but if the attacker is requesting for, let's say, some Elasticsearch data, then in response the server will get the MIME type or the content type as application/JSON, right? So here you can basically very easily perform response filtering. So if you're allowing only images to be requested or PDFs to be requested, then you can basically perform response filtering. And if there is any other data, so if, let's say, you are allowing only images and instead of images you are getting text data or you're getting JSON data, then you can simply go ahead and reject that particular request. And this is the monetary value of SSRF as well. The next kind of attack that we want to look at is serialization or deserialization vulnerabilities, which I'm sure you guys must have heard. I had also delivered a workshop on deserialization at NullCon 2018. Now, deserialization issue is a very interesting issue because it deals with the way data is being communicated. So today, if there are two systems that want to communicate with each other, let's say system A and system B, they want to communicate with each other, then what are the different ways in which they can communicate? One is the system A simply sends the data as a text format or a JSON format or as an XML format, right? These are the three data formats that we know for sure. But there is another way in which we can share data, and that is through serialized communication. Now, what is serialized communication in case of Java? So let's say there is a car object and we want to send the car object from system A to system B. Then all we need to do is basically serialize the car object, right? Package it as a base64 encoding or any kind of an encoding technique, send it over to the network. At the receiving system B, what the system B will do is simply take this serialized string, pass it to the read object function, and create the car object out of the out of this serialized string and create that object in the memory itself. Now, why this technique is more preferred? Because if you were to send the details of the car object, that is the car model and the car capacity, as a JSON string or as an XML string, then the system B will first have to parse that particular string or parse that particular JSON object, convert it into an object of type car, and then start using that particular object. But in case of serialization, the system B only needs to pass that serialized string to read object, and the output is what we get is an object that the application can start playing around with. So the processing is a lot faster in case of the serialized communication. But with every functionality, you can have a security issue. Now, what is the security issue here? That so here is again a sample serialized string, as you can see, and the best way to identify a serialized string in Java is the first 3 bytes of the serialized string. So R, O, and 0 are the first three. Will always be the first 3 bytes of a serialized string. Now, what is the problem with serialized communication is when the serialized string reaches the read object function, by default, there is no way in which the receiving system B can identify which particular class or which particular object needs to be serialized or needs to be deserialized. So an attacker, instead of sending an object of type car, we can send an object of some other class through which he can perform a remote code execution. So for example, we have the VISO serial tool, and VISO serial tool basically generates those kind of objects, which are also called as gadgets, because it's not just one single object. You have to basically perform a chaining of different objects accessing different functions to actually reach the java.lang.runtime function. So this is what the BISO serial tool does for us. It creates a kind of a serialized string, which when given to the read object function gives us a remote code execution vulnerability, right? So, and this is the JBoss CVE ID, JBoss CVE. So as you can see in JBoss, the entire request or the entire post request was being accepted as an input stream, and that input stream was being passed directly to the read object. Now, the problem with the deserialization issues is that there is no easy solution for existing applications, right? So if you are if you are relying completely on serialized input, then you may have to basically change your entire approach of communication. So from serialized string, you may have to go to JSON or XML, which may require an architectural overhaul, right? Secondly, never provide user control data. Again, untrusted input. So we saw different kinds of untrusted inputs, not usernames, not passwords, but XML files, simple URLs, and serialized strings, right? Of course, preferring JSON instead of serialization options is something that you can do. So in PHP, the unserialized function has been deprecated, and instead of that, we can basically make use of the JSON underscore encode and JSON underscore decode functions. Some libraries perform whitelisting of classes. So let's say you are expecting only only class car to be serialized, right? So you can whitelist that particular class. So if the attacker is sending a class of, let's say, java.lang.runtime, it will deny it, right? And there are and there are these automated solutions as well that you can apply in front of your application that basically check if there are any of the malicious deserialization strings coming into your application. And these are some popular bugs in the Java universe for deserialization. So in Java, what we discussed here is simple binary deserialization. However, in Java, there is XML deserialization and there is also YAML deserialization as well. All right. So what are the key takeaways from this webinar that I really want you guys to understand is, first is to weed out application vulnerabilities, developer education is a must because developers are mainly focused on functionality and they generally do not get time to look for security issues as well. Rather than giving checklists of secure coding practices to developers, it's best to teach the developers about the application vulnerabilities as they can relate more with the vulnerabilities when they actually see them in action. Draw attention towards impact and severity of the issues by relating things to money, right? So as I also in the previous slides I discussed about XXE and SSRF, the monetary values. If you attach a monetary value to a particular vulnerability, then it basically helps in creating the impact or helps in explaining the impact, right? Utilize frameworks and libraries that secure by default. For example, if you're using an ORM framework or an object relational mapping framework, then it completely eliminates SQL injection vulnerabilities because an ORM framework goes ahead and abstracts the complexity of writing SQL statements from the developers, right? Of course, you need to take care that, again, you are not going ahead and writing queries of those ORM frameworks. For example, a popular ORM framework in Java, that is Hibernate, also allows you to write Hibernate query language or HQL, and there can be SQL injection within HQL as well, right? Security automation will deal mainly in finding low-hanging fruits like SQL injection, XSS, insecure libraries, insecure dependencies, etc., which will give certain level of assurance to the security professionals so that they can focus on bugs that cannot be caught in automation, right? So you can basically go ahead and also introduce security tools within your DevOps process, which can remove these low-hanging fruits, right? Again, it is important to stay up to date with the security world because hackers and malicious actors do not take breaks or they do not take vacations. They are pretty much active even in this period of COVID-19. So what you can do to basically keep yourself educated is you can follow various security conferences like Black Hat, DEF CON. The OWASP also has a lot of different conferences in different regional conferences, uh, which where they basically have good quality videos and good quality talks, etc. And the videos of those talks are later on released on YouTube. You can basically go ahead and even follow the people who are giving talks and identify the latest vulnerability. So for example, a very well known researcher, James Keatle, he released a very interesting vulnerability, that is HTTP request smuggling using HTTP desync attacks, in the last Black Hat conference, right? So so following these conferences is one way, and following a lot of good security people on Twitter is one way. Another thing that you can do is on Reddit there is an RSS feed which goes by the name NetSec, where people release a lot of good blog posts and material for for education about security. So whenever there is a new vulnerability or a new technique coming out, people blog about it and share it over the NetSec channel. Thank you, everyone.